So hey guys, welcome back to my channel. Hope you're doing extremely well, and this is your very own mask code at this side. So today's question is sorted and rotated minimum. So question is saying that you have an array. You have an array, right? Now this array is sorted. This array is sorted. That is, suppose you have an array 1, 2, 3, 4, 5, 6. This is a sorted array, right? This is a sorted array. Now the question says that pick a point and rotate it. Pick a point and rotate it. That is, if I say that if I pick this point, I want to rotate it. That is, these two elements will come in front, and the array will look something like 5, 6, and now all these remaining elements 1, 2, 3, 4. Right? 5, 6, 1, 2, 3, 4, as given as this array. This is the same array, right? Now, the problem wants you to find in this particular array which is sorted and rotated, the minimum element. The minimum element. There can be duplicates as well, there can be anything, but you need to find the minimum. You need to find the minimum, right? So let us see how will we proceed. Brute force is actually very simple. What is a brute force? Pick an element. Suppose your answer equals to ARR 0, traverse from 6, 1, 2, 3, 4, and HF, amplitude your answer to the minimum of it. That is, answer equals to minimum of answer, comma, ARR I. At the end of the loop, return answer. Return. Brute force is actually very simple. I don't even want to write it. Brute force is running in O of n time. Can we reduce the O of n time? What is the time we are getting? O of n time, and O of 1 space complexity is with us in brute force. Can we somehow optimize it? It is already very optimized, right? Now, what will I do? I will read the question again. The question says sorted. The question is sorted, and we have to find minimum. That is, search. I am getting search and sorted both in the same question. And whenever I find these two credentials, I see, can I think of binary search? Because I know that binary search works in log of n. So that may optimize my answer. Let us try to think in that way. If I try to plot these points on a graph, what will happen? 5 is somewhat here, 6 will be somewhat here, now 1 will be here, 2 will be here, 3 will be here. So if I try to draw a line, 5, 6, 1, 2, 3. If you see, the level between these lines there is some difference, right? Okay. Now what is the minimum point? You can see according to this graph, this is the minimum point. This is the minimum point. That is, first we are going up, 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 then a certain jerk, and then again we are going up, up, up. So there is sorted order fashion somehow. So what will I do? Binary search says to go in a domain that is from low to high. Obviously my low will be at index, let me mark the indexes 0, 1, 2, 3, 4, 5. Obviously because I have to find the minimum in all of the array, I will take my low will be here, my high will be here. Okay, now what? My next step is to find the mid. What is the mid? That will be 0 plus 5 by 2, which is equals to 2.5, and because we are doing an integer division, it will be 2. My mid will lie here, right? We can know that because this is a short array, we know that mid is already lying at minimum element. What will I do? I will say answer equals to minimum of answer, comma, ARR mid. That is also simplified. No problem in this also. You can initialize your answer as ARR 0. That is the first element I am considering as minimum. Okay, now what? Now you have two options. We always know that we actually go high equals to mid minus 1 or low equals to mid plus 1. The option is we have like the condition before us is that we have to choose this. We have to apply this over some condition. Now what are those conditions? Now tell me. Now tell me, because we are being given a sorted rotated array. We have been given a sorted rotated array. Let me take you down somewhere, right? Let me plot the graph again. The graph was looking something like this, right? The graph was looking something like this. I don't care about 5, 6, 1, 2, 3. I don't care about anything. Where can your mid lie? Your mid can lie here, 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 at any point, right? I am taking a random point. Let us take a point here. Let us take a point here, right? Let me mark it. Let us say this is our mid. Obviously, this was our high, and obviously, this was our low, right? Now, where can I say that this part is actually sorted? We know that the part from low, I have two options: low to mid, mid to high, right? If I am saying that I am sure that this part, low to mid, is actually sorted, can I say that? Can I say that the part between low to mid is actually sorted? Part between low to mid is actually sorted, right? If the part between low to mid is actually sorted, what is the condition being followed? ARR low, that is the lowest an element on the lowest low index, is actually less than equals to ARR mid. Agreed? Agreed? I hope you are agreeing with this. That if this condition follows, that means the point is lying here on this particular axis, that is the above axis, and my answer will be lying on the lower axis, right? Now, suppose the point lies here, the point lies here. Now what? For this condition, ARR mid is less than equals to ARR high. That is, here mid to high portion is sorted. Are you able to establish that? That here ARR mid is actually less than ARR high. That means that mid to high portion is sorted. Now if I know that this portion is sorted, can I say that my mid is already shining at the minimum point of the sorted half, that this half is already sorted. Now what can I do? I know for sure that mid element is sorted in this particular half. I want to know the mid element shortest in the remaining part, that is this part as well as this part. So what will I do? I will say high equals to mid minus 1. High equals to mid minus 1. That is a perfect thing to say. If this condition is following, you will say high equals to mid minus 1. And if the above condition is following, I know that this is a sorted part. What will I do? I will update my answer for low and for the unexplored part. What is the unexplored part? This part and this part. What will I do? I will say low equals to mid plus 1. I will say low equals to mid plus 1. Right? My low will come here, and similarly my search will continue up till my low is less than equals to high. As soon as this condition becomes false, I will exit the loop, I will exit the while loop, right? Okay, so let me dry run it for the example we took up above. Our example array was 5, 6, 1, 2, 3, 4, right? 5, 6, 1, 2, 3, 4. Indexes are 0, 1, 2, 3, 4, 5. I am saying that I am initializing my answer as ARR 0, which is equals to 5. Now, my low equals to 0, my high equals to 5. What will be my mid? Mid equals to 0 plus 5 by 2, which is equals to, because it is an integer division, it will be equals to 2. My mid will lie here. This will be my mid. I will update my answer. Answer will change to minimum of 5 and 1. So it will change to 1. Right? Now, I will see which portion is sorted. I will say that 1, 2, 3, 4. ARR mid is actually less than equals to ARR high. That is, this portion is sorted. And because this portion is sorted, this element, mid element is smallest. I have already updated that. So what will I do? I will say high equals to mid minus 1. High equals to mid minus 1. That is, high will come here. Now, what will be my new mid? Which will be equal to 0 plus 1 by 2. Because it is an integer division, it will be equals to 0.5, that is 0. My mid is actually lying here. Now which portion is sorted? Now because we are using something like this, if ARR low is less than equals to ARR mid, and in the else condition we are saying ARR mid is less than equals to ARR high. You can also reverse this, there is no matter. If we are using this particular scenario, you can see that in this particular case, ARR low is also 5, ARR mid is also 5. So 5 is less than equals to 5. That means my first condition will work and second condition will not work, right? But you can also reverse this order to make second condition work first. So what will happen now? You can see that first portion is also sorted and second portion is also sorted. First portion is 5, and second portion is 5 6. Both of them are sorted. A single element is sorted in itself, right? So what will happen? You will say that first part is explored. So what will you do? You will compare it with low. So 1 and 5, no matter. Okay, so low will be changed to mid plus 1. That is, mid is here, low will come here, right? Now both of them are lying at 1. My new mid will be 1 plus 1 by 2, which is equals to 1. My mid will come here. And again, first part, like low to mid is 6, mid to high is 6. Both of them are sorted. My first condition will work and I will update my answer, but it will not get updated because 1 is already minimum. So my mid will change to, my low will change to mid plus 1. That is, my low will come here. And as soon as it comes here, my high becomes less than low and I will exit the loop. Now as you can see, my answer contains 1 and I have already explored all the potential parts of the array. What is the time complexity? Because at each point I am halving my search, it will be log of n. Binary search time complexity and space complexity O of 1, not using any extra space rather than some variables, right? Like high, low, and mid. So I hope the approach is clear to you. I hope the question is clear to you, and it is time for us to move to the coding area. Any doubt, any suggestions, any recommendation, any compliments, any comments, please go to the comment section. I will surely get back to any of your doubts. So here we are in the coding section. What will I do? First, int answer equals to arr0. First thing, low equals to 0 and high equals to n minus 1. That is arr dot size minus 1. Second thing, while low is less than equals to high, first step is to calculate the mid. So mid equals to low plus high by 2. Now what will we do? Now update your answer. So answer equals to minimum of current answer and mid element, that is ARR mid. Now the condition can be if ARR low is less than equals to ARR mid, that is low to mid portion is sorted. So update your answer. So answer equals to min of answer comma ARR low. And now because we have explored low to mid, we can go low equals to mid plus 1. Else, I can also write else if ARR mid is less than equals to ARR high. In this particular portion, we have already chosen mid here. We have already updated our answer for ARR mid, which is the minimum in ARR mid to high. So what will we do here? We will just say we will just say high equals to mid minus 1, right? Because we need to explore the left part of it. Now return your answer. As simple as that. This is simplest question I've ever seen. Let us see the results. Working fine for the sample test case. Let us see for the submission test cases as well. Working absolutely fine. So thank you for watching. Hope you liked it. Make sure to like and subscribe to the channel. Thank you. Have a nice day.